Question number 9. A ship sails from point A to point B, which is 15 kilometers from A, on a bearing of 42 degrees. So the ship sails from point A, which is 15 kilometers from point A to point B, which is 15 kilometers from A on a bearing of 42 degrees. The ship then sailed to C, which is 19 kilometers from B, on a bearing of 130 degrees. The following diagram shows a sketch of the ship's journey. On the diagram, insert the 42 degrees, the 130 degrees, calculate the distance between town A and C. So we need this distance here. All right, to get this distance, I first need this angle here. All right, which we can find. I need this angle here, which I'm saying we can find, especially if we extend this line. So this line divides the angle at B into two halves. This is alpha, and this is beta. All right, what I need is the sum of alpha and beta. Now, looking at the diagram, it is clear that alpha is equal to 42 degrees. They are alternate angles. Beta plus the 130 are angles on a straight line. Beta and the 130 are angles on a straight line. So beta would be equal to 180 minus 130 is equal to 50 degrees. They are angles on a straight line. And so angle ABC would be equal to 42 plus 50, and this is 92 degrees. So the entire angle here is 92 degrees. Now, I know the length of two sides of a non-right angle triangle, and I wish to find the length of the third side. That is a condition for applying the cosine rule. The cosine rule is C square is equal to A square plus B square minus 2AB cosine C. Now in the formula, C is the side opposite the inclusive angle, which is 92 degrees. So this is x squared. A and B are the other two sides. So this is 15 squared plus 19 squared minus 2 times 15 times 19, the cosine of the inclusive angle, which is 92 degrees. All right, so to find out what x, which is the length, which is the distance between the two towns, I would simplify the square root of all of this. The opposite of square is square root. So I would just punch this exactly the way I have it here in my calculator and then press equal. So x would be equal to, and x being the distance between the two towns, the square root of 15 squared plus 19 squared minus 2 times 15 times 19, the cosine of 92 degrees, then press equal. And what I am getting is 24.6 kilometers. The distance between towns A and C is 24.6 kilometers. Next, we're asked to determine the bearing of town A from town C. The bearing of town A from town C. All right, the bearing of town A from town C. Remember, bearing is measured clockwise starting from north. So this angle here represents the bearing of town A from C. Now let's see how we're going to get that angle. Well, to get that angle, it would be good if we know this entire angle here. All right, remember we know that this is 50. So we know that this piece here is also 50. There are alternate angles. This piece you don't know, I'm going to call it theta. Now to find theta, I'm going to have to use the sine rule. Because after I use the cosine rule on a triangle, the next rule I'm going to use is the sine rule. So it's going to be the sine of theta over 15 is equal to the sine of 92 over 24.6. So the sine of theta over 15, yes, is equal to the sine of 92 over 24.6. Bring this up here. We have sine theta is 15. Sine 92 divided by 24.6. So that is 15 sine 92 divided by 24.6. I'm just taking 3 decimal places. 0.609. So theta is sine inverse 0.609. Theta would be 37.5 degrees. All right, so we can probably work with 38. So back to our diagram. This is 38 degrees. This is 50 degrees. And the remainder of this angle is the bearing of A from C. Now, the bearing of A from C. Bearing of A from C is equal to 360 minus 38 plus 50. That's 360 minus 88 and what we have is 272 degrees. The bearing of A from C is 272 degrees. B says the points L, M, and P lie on the circumference of a circle whose center is O. The line NP is a tangent to the circle at P. O OMN is a straight line. The line PL is a diameter, and angle ONP measures 24 degrees. Calculate the value of each of the following angles, show detailed working where necessary, and give a reason to support your answer. The first angle we want is angle PON. Angle PON. That would be this angle here. Now, what I'm going to use to find it is the fact that this angle is 90 degrees. So that angle is 90 degrees. I'm going to tell the examiner that angle PON is equal to 180 minus 90 plus 24, which would be 180 minus 114 degrees. This angle here is 66 degrees. So this is 66 degrees. And remember, I'd have to tell the examiner that angle OPN is equal to 90 degrees. The diameter at point of contact is equal to the angle, is equal to, is at right angles, is at right angles to the tangent. So the diameter at the point of contact is at right angles to the tangent. Angle PON measures 66 degrees. Next, we need angle PLM. PLM, that would be this angle here. It might look difficult, but the angle is actually 33. And this is essentially the reason where the angle at the center is 2 times the angle at the circumference. Start at P to center down to M. Next one, start at P to circumference down to what? M. The one to the center is called the angle at the center. The one to the circumference is called the angle at the circumference. This is 33 degrees. Angle PLM. Angle PLM is equal to 66 divided by 2 is equal to 33 degrees. And the reason is angle at center is equal to 2 times angle at circumference when both are subtended by the same arc or chord. Angle PMN, angle PMN, angle PMN. Let's identify it. PMN. That's this angle here. PMN. We need this angle. All right. How am I thinking I'm going to find that now? I know I can. I'm going to use the fact that this angle is 33 degrees and that the angles in a triangle add up to 180 degrees. So first I need to tell the examiner that MPN is 33 degrees and Y. Angle MPN is equal to 33 degrees. This is the reason. The angle between tangent and chord is equal to angle at point of contact. Let's add that. At point of contact is equal to angle in alternate segment. All right, so that's the reason why that angle is 33 degrees. This is it. This is the circle theorem for that. If that's my tangent, all right, let's not recognize that tangent. This is my tangent. If this is 33, this is also 33, because the angle between the tangent and the chord at the point of contact P is equal to the angle in the alternate segment. So now angle PMN, angle PMN would therefore be equal to 180 minus 24 plus 33. This is 180 minus 57. This is 123. 123 degrees.